Hello everyone, we're going to solve today problem number 45 from chapter 3 section 4 of Precalculus Blitzer. We are right now covering solving logarithmic and exponential equations. So the problem that I have proposed today is problem number 45, which says e to the 4x plus 5e to the 2x minus 24 equals to 0. In this case, we're going to start by saying, for example, that the given equation that we have is in quadratic form. Now, it is not pretty obvious because we need to do some modifications. So if we let, for example, if we do some modification, if we let this e to the 2x to the second power, because I can do power of a power, 2 times 2 equals 4x plus 5 e to the 2x minus 24 equals to 0. Now I'm going to do something that you're going to use in calculus, which is a change of variable. I'm going to call it change of variable, but in this case we are making a change in your exponential function. So I'm going to let u equals to e to the 2x. So I'm changing this e to the 2x. So now this exponential function is exponential equation is becoming u squared plus 5u minus 24 equals to 0, which is just a trinomial. Is a quadratic equation that we can solve by factorizing. So I'm going to use the X method. This is the one that we used in class, where I take the independent term, the negative 24, and put it on top of my X. And then I take the middle term, positive 5, and put it at the bottom. Then I ask myself, I need two numbers that multiply each other will give me negative 24, and if you add them or subtract them will give you 5. I have two numbers. In this case is 8 and negative 3. 8 times negative 3 is negative 24, and 8 minus 3 is equals to 5. So what I'm going to do now, okay, we are going to write u plus 8 times u minus 3 equals to 0. So I just take these two numbers and place it in the parentheses. U times u squared, u minus 3u. 8 times u is 8u. 8 times negative 3, negative 24. And then remember that we have in this case 8 minus 3 is equals to 5. So now if we apply the zero product property, we have that u plus a is equals to 0, or u minus 3 is equals to 0. And then we solve for u. So we have u equals to negative 8 and u is equals to 3. Let's not forget that we have this change here. So we need to return this u to the original expression. So I'm going to have e to the 2x equals to negative 8 and e to the 2x is equals to 3. Now, how do we get rid of this e to the 2x? We're going to apply natural log on both sides of the equation, okay? So I'm going to have here ln e to the 2x equals to ln negative 8. This ln will, I'm going to say, cancel out this e. That's the property. So I have 2x equals to ln to the ln negative 8. Then we divide by 2. So x is equals to ln negative 8 over 2. Now we have a problem with this solution. They are going to ask us to check your solution, but in this case I have log of a negative number, which is not defined. Logs are not defined for negative number. So this one is not going to be your solution. So I'm going to solve this second part. So I have ln, or natural log, of e to the 2x equals to ln of 3. The ln will remove the exponential, so I have 2x equals to ln 3. Then we divide by 2 both sides of the equation, so x is equals to ln 3 over 2. This ln 3 is positive over 2, so it's a positive solution. I'm going with this one. You can prove it. You can go back to the original equation, plug in everything in the calculator, and you're going to get the number checking equals to 0. So remember that in this case, they're asking me for the exact solution and the approximation. So my exact solution is ln 3 over 2, and the approximation, or in this case, my approximation is x approximately equals to 0.55. So those two, you can leave the exact solution. That's what the textbook asks, or you can leave it a decimal approximation. It's up to you what the textbook is asking. In this case, the textbook is asked both as the exact and the approximation. So this is the way we're going to solve problem number 45. If you have any question, please leave it in the comments, and when I have the time, I will reply to your question. Have a wonderful day.